Welcome to GoggleCam, the internet's first-person video of how to do lab.
Once you've set up your temperature baths, you're going to prepare the battery for testing using this holder. And you don't want the battery to get wet, so we're going to put the whole thing inside this plastic baggie. So the battery goes in the holder, the positive side up. Now, so here's the wires coming from the potentiostat, which is inside the computer. So it's the cable coming out of the back of the computer. And what we want is the mouse pad shows you what the different colors mean for the different electrodes. So we want the working green and working sense blue both to be connected to the red wire. So one way to do that is to connect one of the clips and then clip the other clip to it. On the black, we want to connect the counter electrode, which is red, and the reference electrode, which is white. So the red and the white, and this is tricky because the orange looks kind of red, so we want the red, not the orange red. And then we don't want anything else touching anything else. We want to put this inside a baggie before we put it in the water. So we want the water to provide temperature. So I want to be sure to immerse it in the water, make sure the battery is being surrounded by this water. It's warm or cold water depending on your water bath. Let that equilibrate for a few minutes. Make sure the other electrodes aren't touching anything. Now to measure the temperature, we have this thermocouple immersed in the liquid. So we turn that on and we see that's the current temperature. And we want the computer to collect that for us. We're going to turn on this software, HH506RA. Prior to starting the video, I'd already plugged in the meter. The thermocouple goes into the T1 slot. See, there's the T2 is empty, T1 slot is where I plugged it into, and there's a positive and negative side to the thermocouple, so you have to get it lined up. You see they're different sizes, that helps you. So that's in the T1 position. I attached the optical interface to the meter, which goes to a serial port in the back of the computer. We want to connect it to the COM1. Then we can go to the T1 input, because that's the thermocouple that's connected. And so this is the live reading, 40.6, 40.7. Okay, it's changing. It's not quite the same time frame, but so that's working. We're getting a live reading. To save the data, we press record, and this will pull up the live reading at every second here. We don't need every second. We can change this to 30 seconds. And we want 900 seconds of data. It's about 30 times. And actually we're going to be changing the temperature bath, and we can just keep recording the data, and you'll know which temperature bath you're at a particular time. Now you need to change the file name, and so you might want to put your initials here and then press record, and it's going to go to that KED24. Right click in the file name window, let's see, to browse the path to find the right file name. This is the clunky software. So many seconds are passing while we wait for this to register that we're doing something. So we right click, it says has an error. What we're going to do is continue, and it will ask us for a path name. There, after we waited a while, this popped up. So we want to put this in a folder where we can find it again later. So now it has a path name, and it's going to save all these numbers to that file that we can open in Excel. We want to record the electrochemical data, so open Gamry framework by double-clicking on this. And up here it should turn a green light to the PCI 4G300, which is the potentiostat inside the computer. That's the one we want to use. The experiment we want to set up is under physical electrochemistry. It's called chronopotentiometry. We're going to measure the potential over time. This is where you can put your file name that you want. So this is our sample code, and this is the 40 degree 39.6. This is the 40 degree water bath. That's how big the battery is, 7.5 millimeters. We're going to apply a small draw current, 5-second delay initially, so everything equilibrates. We want to do this for 900 seconds. Every 30 seconds we'll collect the data point. Lower limit to be 0. We want to start at 0 volts, and we want to go up to 4 volts for this particular battery. Everything else should say off. Click OK when we're ready to run. It's going to automatically save to this data file, as well as give us a live data read. So we had a 5-second equilibration period. It's running that now. Now it should begin every 30 seconds gathering a data point. Once you're done running the data, you can find the data file under this path name. It's the My Gamry data folder in the public documents, and I'll show you how to find that after we're done here. So you can see after 30 seconds we got our time 0 data point. We're drawing 1 picoamp of current. Our initial voltage is 3.29 volts. It'll keep doing that. When you're done, close that window, pushing the F2 skip button like it says. To find your data, it was saved to the My Gamry data folder. And find your, this is years worth of data. Find your data here. And you can open this with Excel.